speaking at React Miami today. I was planning to be there in person, but unfortunately I wasn't able to make it due to some underlying circumstances. However, I am super thrilled to be able to be here virtually. I wanted to give a huge thank you to the React Miami organizers and team for being able to make that possible. My name's Ashley, and I'm a community engineer at Mux, where we're working to make video easy and fun for developers to use. I'm also a developer advocate for the tech conference and organization, Render Atlanta. Today, I'm going to be talking about something amazing, the magical world of live video. Video brings us so many wonderful experiences in our everyday lives. Within all of the online video experiences you could have, video typically will fulfill one of two purposes, either consumption, which includes entertainment and information, or communication. But at the heart of these online video experiences is the ability to live stream video, which allows for dynamic experiences where we can be anywhere at any time. In my opinion, this is the perfect intersection of consumption and communication. An example of live video are things like concert feeds or Twitch streams. Because of the value that video can bring, as developers, naturally it's going to be a really intriguing technology to want to explore. But, and I will be the one to say it first, building with video, especially live video, can feel absolutely terrifying. So what do? How do we make this easier and democratize building with live video so more people can feel empowered to jump in? No worries, I've got you covered. In this talk, we'll dive into 7 considerations for building with live video. Then we're going to see a demo of an in-browser live stream app I built with React and a code walkthrough of that. Finally, we'll talk through some takeaways of what we've learned here today. So, this is all super exciting stuff. Let's go ahead and dive into our 7 considerations. The first consideration is video quality. There are 2 primary influencers of video quality, a video's bitrate and its resolution. Higher bitrate will lead to smoother playback, and higher resolution will increase visual quality. Ideally, we want a balance between both high resolution and high bitrate. Another consideration when building with live video is keeping track of live performance and metrics. Real-time metrics are important for monitoring your stream and also for quicker identification for issues as they arise. Tracking of live performance can also help identify patterns at a higher level for what needs to be improved overall in your application. Another factor is cost. A lot of live streaming providers can charge based on things like number of account users, number of viewers, hosting bandwidth, and video storage size. These are all things to consider when building your app, especially since with live streams, the file sizes tend to be more dynamic. The fourth consideration when building with live video is building to handle request volume and fluctuation. Having too many requests at once can overwhelm your system. This can cause situations like lagging or even the system disconnecting completely, so choosing the right architecture and infrastructure to handle fluctuations will be really valuable. Next up is video latency. Latency is the amount of delay between the time a video stream transfer is requested and the time it actually starts transferring. Low latency is going to be our ideal here. The less delay there is, the better the experience will be. The sixth consideration is cross-device compatibility. Cross-device compatibility for your stream will come from choosing the right video or media player to actually display your stream, and just making sure that the player is going to be well supported across a variety of browsers, platforms, and devices. And finally, last but definitely not least, one of the most important considerations is accessibility. Some good accessibility practices are using live or auto-generated captions, having dual streams to feature a sign language interpreter alongside your own stream, and making sure your media players are screen reader compatible. So now that we've covered our considerations, let's get into the exciting part, building a live video app. The app will allow you to stream live with a camera and audio input in browser. In my case, I'm going to be using Google Chrome. The application we're working with is one that's already based off of an existing Mux blog post called The State of Going Live from a Browser. This was actually written by our current head of DevX at Mux, my boss, Matt McClure. The app will use Next.js, which is a React framework. We're using Next.js so we can implement a custom node server alongside our application without having to run everything on multiple ports. The custom server will receive and send our video data. So to get started, we're going to need a few tools to help us build our app. The first one is the WebSocket API, which will allow us to create connections between our browser and the custom server we are configuring. The next tool is the Media Recorder API. This records inputted media by taking in media stream objects such as audio or video. We'll also be using FFmpeg, otherwise known as FFmpeg, which will allow us to actually send that outputted video data in real-time chunks to our publishing source. And finally, speaking of our publishing source, we'll be using Mux's live streaming API to receive our stream. We'll send the outputs to Mux using a provided RTMP, otherwise known as Real-Time Messaging Protocol server URL. We want to use Mux because it allows us to easily access the stream for playback anywhere, and it provides really easy built-in performance tracking. So this is a preview of what the live video app flow will look like all together. We'll go ahead and start in the app where we'll enable our camera and audio. As you can see here, there is an input and an output screen. So the input is showing me the direct feed being captured from my camera, while the output is an HTML canvas that is being continuously updated and reanimated with the media from my input. On this canvas, I can also add overlay graphics, and that will be sent as part of the video in the stream. So in this example, I have Welcome to Stream with Ashley as my graphic. I'll go ahead and enter in a stream key for a live stream I've already created on the Mux side, which currently has no active connections. So once I input it, I'll switch over to the Mux side and check on the status of it. As you can see, it is connected and has started recording. I'll then hop back over to my app just to make sure things are still running smoothly and everything is mapping pretty well. And now hopping back into the Mux side, you can see my stream is now active and you can see the playback here on my Mux dashboard. So it's all super exciting stuff. That is the app in full, and you can also stop the stream on the app side once you're ready to finish. Before we dive in more, I did also want to give a really important disclaimer about in-browser streaming. Typically, we don't recommend live streaming from a browser over something like using a native streaming tool such as OBS. This is just because the browser will provide a less reliable stream with decreased quality. However, with that being said, live streaming from the browser can definitely be way more accessible and offer way less friction. And for me, just because it's a more accessible entry point with more familiar tools, I really wanted to dive into what the in-browser experience would look like here today. So now that we've gone over what we're building and what tools we'll be using, let's go ahead and get into some code. So to start off, this walkthrough will assume a traditional Next.js project setup. So we'll just be using the create next app package to set it up. So once that's ready to go, we'll just start in the front end in the pages folder in the index.js file inside that folder. So first we're going to use state hooks to initialize some state variables to keep track of things related to display, so specifically like UI settings, such as whether the stream is connected or what stream key has been inputted. We'll be using ref hooks to actually keep track of data that we'll need for part of the live stream functionality, such as things like the video input itself, the current WebSocket status, and the canvas that we're going to be repeatedly updating to send it out as our video output. Next, we're going to create a function to access the device camera and microphone to get our audio and video. This is just going to be using the getUserMedia function. And then once we grab that, we're going to populate that into our input stream ref to actually store it. We're then going to set our input video element so that it can consume that audio and video from the input stream and play it back. Then we're going to set up our output canvas by setting its dimensions to match our input video, and then calling a function to repeatedly update and reanimate the canvas, which we will dive into here next. As mentioned, in our update canvas function, we are just sending the HTML canvas output as our stream generally, so we will need to, in this function, continuously update it so it currently reflects our input. We're basically requesting a redraw of the canvas that matches the input, and then repeatedly calling that update canvas function over and over for reanimation. Next, we're going to need to create a function that will actually allow us to start streaming. In the first half of the function, shown here, we are initializing the WebSocket connection so that it communicates with the server that we're going to build in the backend. We're passing in our Mux stream key so it can be used in the backend server. And I also included an example of an event listener for our WebSocket since it's event-driven. So in this case, the WebSocket is set up, its status is set to open. So when that happens and an open status is detected, it will then set the connected state variable in the UI to true. In the second half of the function, we are then getting our audio and video tracks as media stream objects and then combining them into one output that we will then send data with using our media recorder API. I also included an example of a media recorder event listener since this is also event-driven. So in this particular case, if data starts becoming available to send from the media recorder, then our WebSocket will actually push that data to our backend server. So finally, we will need a function in the front end that will end streaming. So as you can see here, it's just going to terminate our media recorder connection and then set a state variable that indicates the stream is now over. So once the project is set up in the front end, we can now get into configuring our custom backend server. So to initialize a server, we're going to create a server.js file in our root project directory. And then we're going to use a built-in create server function to go ahead and create a server when the app is launched as indicated through the app.prepare function. Once that server instance has been initialized, we're going to pass that newly created server into a new WebSocket server instance, and that will help initialize our WebSocket server. Now that we've got that covered, let's go ahead and add the logic for the WebSocket server to listen for requests from the WebSocket that we set up in the front end. When the WebSocket server has connected, it will initialize an FFmpeg instance. I didn't include the encoding settings that you would normally pass in as the first few parameters just because it tends to be really lengthy, but that is easily available online, so feel free to look that up. And after that, you also want to specify the destination that you are sending that data to. So for us, we are using Mux's RTMP URL as our destination, which will also use the inputted stream key that we passed in from the front end. This stream key will just let Mux know which stream we're actually trying to send our data to. Then we're going to execute some logic to continuously listen for WebSocket and FFmpeg events, such as data transmission or statuses sent from the stream. FFmpeg will continuously send data chunks to the Mux RTMP URL as the stream continues. You can see examples of the FFmpeg and WebSocket event listeners here. The FFmpeg one is listening for data and sending a response to the WebSocket, while in the WebSocket event listener, it's listening for a message event, and when found, it uses FFmpeg to actually send that inputted message. Lastly, we're going to need to update our package.json to configure our custom server to run alongside our app. And we also need to add in the WebSocket package that we're using, WS under dependencies. Our custom server in development, we'll be using something called NodeMon, which is just a custom node wrapper that will actively monitor for changes and update the node application when those file changes are detected. And finally, that's it. That is our app. So now that we've walked through the code, let's go ahead and chat about some takeaways. So in the first half of this presentation, we went into 7 considerations for building with live video. Those considerations were to optimize for quality, request volume and latency, factor in costs, be intentional with accessibility and cross-device compatibility, and making sure to add in performance metrics to track stream quality. All of these considerations can feel intimidating, especially if you're a newcomer. However, as we saw in the second half with the demo and code walkthrough, it doesn't have to be that way. All in all, the bare bones version of the demo app had a backend server file and a front-end index file that were each less than 200 lines of code. They both also used free and openly available tools like the WebSocket and Media Recorder APIs. With that, we were able to create a super fun in-browser live streaming app that sends its stream to Mux to allow for live playback. So as we talked about earlier, the world of live video is incredible and it's magical. It's really instrumental with how we work and live in today's world. It allows us to consume more information and communicate more, and it's only going to get better from here. I hope this talk made you excited about video too. So now that you've seen it in action, I challenge those of you in the audience to build an application with live video. I would love to see what you make. And with that, thank you so much for taking the time to listen to this talk. I would love to stay connected through email. You can reach me at ashley@mux.com, and you can also find me on Twitter at ashley_in_tech. You can find the repository for the demo app I presented at the link cutt.ly/live-stream-app, and just make sure that's all lowercase. If you have any specific questions about Mux, some members of my team have a booth at React Miami, and they would be so happy to chat with you, so please make sure you stop by. I also want to say a huge thank you to my team at Mux for all of the support they offered me on this talk, and of course, a huge thank you to the React Miami team and organizers for the opportunity to be able to share the magic of live video. Thanks so much, everyone.